we're going to look at quadratic applications, in other words, word problems. We'll start with the review. What is the vertex of the quadratic above? This is in vertex form. You should easily be able to see how it shifts. So think back to shifting up, down, left, and right. This is plus 9, which means it moves right, or not right, left 9. And the minus 3 means it moves down 3. So think about taking the parent function, which is at 0, 0, and shifting it left 9, down 3. The vertex would be negative 9, negative 3. Is it U-shaped up or U-shaped down? Well, we have this negative right here, so it's going to be U-shaped down. If you didn't know, you could put it into your graphing calculator. Today we're going to look at applications and calculator matching. When you read a real-world problem or a word problem, you should ask yourself these questions. What is the question asking me to find, and how will I solve it? And methods for finding the zeros or the x-intercepts. You could use your graphing calculator and graph it. You could factor it and use zero product property. Or you could use quadratic formula. So we know 3 methods for finding the zeros. How about finding the vertex, the highest or lowest point, depending on if it's U-shaped up or U-shaped down? Again, we could use our graphing calculator and analyze the graph. Or we can use this method where we find x as the opposite b over 2a. And then for y, you're going to plug in x and solve. And we're going to practice all of these methods today with word problems. So the first example, Graham jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by this function, where t is the time in seconds and h is the height in feet. So again, here is Graham on the cliff, and he's going to jump up and then down. How long did it take Graham to reach his maximum height? So you have to determine, what are we finding here? We are finding the vertex, and if it's time, how long, that would be the x value. So to find the x value, we're going to take the opposite, b over 2a. Opposite of 16 is negative 16 over 2 times negative 16, which would be 0.5. So after 0.5 seconds, Graham would reach his maximum height. What is the highest point that Graham reached? That's the y value, the height. So to find that, we plug in the time in which he reaches his maximum height into the original function. So h equals h of 0.5, I'll just write h. Negative 16 times 0.5 squared plus 16 times 0.5 plus 480. And then you just type that in to find his maximum height. And you do that, and I think you get 484. So he jumps 4 feet higher than where he started from after 0.5 seconds. Next question. Graham hit the water after how many seconds? So if we take a look at this, we're looking for, right, when does he reach a height of 0? So we're going to set our equation equal to 0. 0 equals negative 16 t squared plus 16, I think it was 16 t plus 480. And you can factor and use zero product property. You could look at your graphing calculator. I'll practice using quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And let's figure out the 3 different numbers. So let me type this in. 16 squared minus 4 parentheses negative 16. 480. So it'll be negative 16 plus or minus the square root of 30,976 all over negative 32. Let's break this up into 2 answers here, and I'll type in my calculator. Negative 16 plus the square root of 30. Oops, I typed that in wrong. So the square root of 30,976. Hit enter, and then we'll divide by negative 32. So one is at negative 5. And then type in the other one, negative 16 minus this guy, divided by negative 32, and we get 6. The reason we get 2 answers is, imagine one of our zeros is that negative 5 over here, but the 6 is the one that we're looking for. So after 6 seconds, Graham will hit the water. All right, let's do one last example, and then there's an in-class activity, which I won't show on the podcast. You throw a water balloon into the air so that its height, h in meters after t seconds, is this function. How high is the balloon after 1 second? Well, it's giving you the time, so you can plug in for t. Height equals negative 16 times 1 squared plus 20 times 1 plus 2.4, and then you just have to type that in your calculator. So it'll be negative 16 plus 20 plus 2.4. Okay, so the height is 6.4 meters after 1 second. For how long is the balloon more than 5 feet high? So if I draw a picture of this, we start at 2.4 meters, it's going to go up and then down, and we want to know for how long is it above 5 feet. And I should put meters to keep it consistent, 5 meters. Okay, so if it's above 5 meters, we're looking for these 2 points right here. 5 equals negative 16t squared plus 20t plus 2.4. We can use quadratic formula, but we need 0 on one side. So first step, we'll subtract 5 from each side. We'll get negative 16t squared plus 20t minus 2.4 minus 5, 2.6. And this will be our height. Let's use quadratic formula. I'll need a new page here. So quadratic formula, x equals opposite b plus or minus the square root of 20 squared minus 4 AC, so negative 16, negative 2.6, all over 2a. Okay, let's type this in. X equals negative 20 plus or minus the square root 20 squared minus 4 parentheses negative 16 parentheses negative 2.6 to 33.6 all over negative 32. Let's split this up. We get negative 20 plus the square root of that. Hit enter. Divide by negative 32. 0.147. Okay, so this is seconds. And then let's do negative 20 minus the square root of 233.6. Enter. Divide by negative 32. And 1.10 seconds. So between 0.147 seconds and 1.1 seconds, our ball is above 5 feet. What is the maximum height of the balloon? Okay, so maximum height of the balloon, we need two things, x and y. So first x is opposite b over 2a. All right, so b is 20 over 2 times a, negative 16. All right, so negative 20 divided by negative 32 is 5/8, 0.625. To find the height at that time, we plug in, or I should say h equals. So height equals negative 16. We have 0.625 squared plus 20 times 0.625. We're just plugging into the original equation. Plus 2.4. Negative 16.625 squared plus 20.625 plus 2.4 at 8.65 meters. Has its maximum height. And lastly, when does the balloon burst? As it hits the ground. Okay, so as it hits the ground, again, quadratic formula, this time with a 0, equals negative 16t squared plus 16t plus 2.4. And again, we can use quadratic formula. We could try to factor it and use zero product property. Oh, it was a 20, not a 16. So it should be a 20. But since we haven't used a graphing calculator yet to show the zeros, I will show that. So let's open a new graph page. And let's type this in. Negative 16, and we have to change the t to an x squared, and I think it was plus 20x plus 2.4. I better see if I did that right. Hit enter. And we're looking for the zeros. When does it hit the ground? One's negative. We don't want that one. So let's do menu, analyze graph. Let's do our 0. And we can see that at 1.36 seconds, it hits the ground. So your assignment is a mixture of these. You have to determine, is it a 0, is it a vertex, how am I going to solve? In class, we'll do one more activity, calculator matching activity, which we'll skip for now. So your assignment will be the next 2 pages, so work on that and bring any questions to class.